This is part of our video series on human-centered evaluations for NLP explanations. Check out the link for more resources. You're currently here.
Hi, my name is Vera Liao, a researcher working at Microsoft Research Montreal. I will present this part of a tutorial together with Alison Smith-Renner, a research scientist at Dataminr. So with the background knowledge of human explanation and current explanation algorithm, we can now transition to talk about how to conduct human-centered evaluations for explanation. We'll start with application-grounded evaluation by conducting human subject studies. Alison and I will alternate for this part, starting with me giving an overview of application-grounded evaluation. Alison will take over to give a crash course on experiment design to conduct human subject studies. I will then illustrate how to design experiments with 3 use cases of explanation. Alison will close this part with discussion on some challenges and consideration for conducting human subject studies. So we'll adopt the term application-grounded evaluation from Dosh-Velaz and Kim's paper towards a rigorous science of interpretable machine learning. The paper proposed 3 levels of human-centered evaluation for interpretability and explainability. Recall Tanya discussed that the effectiveness of explanation should be determined by whether they achieve explanatory function, that is, what people hope to achieve with explanation. And there are diverse explanatory functions depending on the context where explanations are sought. Therefore, ideally, you would want to conduct evaluation with a real application task where the AI explanation will be sought by involving humans to perform the task and then evaluate whether explanation can help them achieve their task goals. Admittedly, this kind of application-grounded evaluation are usually costly to do and not always feasible in practice. So Dosh-Velaz and Kim suggest that a compromise in evaluation precision can be made by conducting simplified human-grounded evaluation by still involving human by using a proxy task. Or with more sacrifice for precision and ecological validity, you can conduct proxy evaluation by defining certain automatic metrics that reflect human desired properties. So this part of the tutorial will focus on application-grounded evaluation. In the next part, Samuel Carden will introduce proxy evaluation. I want to also briefly talk about human-grounded simplified evaluation. In fact, they are common in recent AI and NLP research that conduct evaluation with human subjects. Devoid of real task context, these evaluation studies use a simplified setup by asking human subjects, often crowd workers, to predict a model output based on the input and explanation. The idea is that if humans can understand how the decision process works based on the explanation, they should be able to simulate the output. These tests are therefore often called simulation tests. However, recent human-computer interaction work warns that this kind of simulation tests have limitations, and they may fail to predict if an explanation method would actually work in real usage contexts. I will briefly touch on 2 reasons for such limitation. One is that simulation tests can only evaluate whether explanation can help people understand the model in isolation. They do not evaluate how well people can utilize the explanation, whether to judge if the model is wrong or to determine follow-up actions. Second, this kind of artificial setup does not reflect how people actually pay attention to explanation and engage qualitatively in real context, and thus risks producing evaluation results that may not have ecological validity. For example, for the simulation tests on the left, it is easy to simulate that the AI would predict this is a high-fat diet just by the explanation that the model recognized avocado and bacon in the image. But in an actual decision support task, to achieve better decision outcome, what the user cares to know is whether this is a wrong prediction. To do so, they must identify that the model misrecognized beets as bacon, which will require them to both pay attention to the content of highlighted features and reason with explanation. Now let's talk about application-grounded evaluation. Some of you might wonder, I'm developing an algorithm. Why and when should I care about applications? Many algorithms are driven by application. For example, you may be developing an explanation algorithm specifically to help people understand and debug language model, or apply to medical data to support doctors' decisions. Sometimes these downstream use cases are implicit in the assumption that the algorithm makes. For example, you may be developing an algorithm to generate a global explanation, and they're usually more useful for tasks like debugging or auditing, but less so for supporting decision making. More importantly, from a responsible research perspective, it is necessary to articulate what are the suitable use cases and what are not for the algorithm, and conduct evaluation accordingly. Sometimes it requires conducting evaluation for multiple types of use case to help you identify the suitable and unsuitable ones. For example, you may discover for post hoc explanation, it may have significant limitation for some downstream use case. It is critical to warn against using the algorithm for such use cases. So really, you should always conduct application-grounded evaluation if you have the resources to do so. Now you may wonder, there can be infinite numbers of downstream applications. Where should I start? Fortunately, it is possible to cluster similar objectives people seek explanation for and consider a limited number of prototypical use cases. Also, by considering use cases, the evaluation can focus on the immediate objective the explanatory function should serve, without worrying about different needs for explanation at different usage points of application. Here, I will use this taxonomy that I discussed in a recent book chapter I wrote with my former colleague Kush Varshini. That is, AI explanation can be sorted for 6 use cases. First one is to debug and improve the model, to support decision-making or action, to audit for compliance, including fairness, privacy, security concern, to calibrate the trust or capability assessment, to support adapting usage or control, and for domain learning. Do note that this taxonomy is necessarily incomplete, as researchers and practitioners will keep discovering new use cases for explanation. Also, these use cases focus on direct users of AI. For example, a recent Kai paper by Suresh et al., the author developed a framework to characterize stakeholder needs for explainability. The immediate objectives they identify are largely consistent with our taxonomy, but there are also new objectives such as contesting AI if you also consider downstream impact for stakeholders who are not direct users but whose life can be impacted. One case in point is loan applicants. It is somewhat tricky to evaluate downstream impact with control studies, so we will limit to the rest of our tutorial 2 use cases of direct explanation users.
This video isn't the end. You're currently here. If you're lost, click on the link below for source code, slides, and other resources.